Could you put the first slide on, please? What I'm going to tell you about briefly this morning is a collaboration we've had with the pharmaceutical industry, which has been going on quite a long time. It's actually just entering its 18th year. So I'm going to sort of tell you basically briefly how it works, why it's lasted so long, how it could work better, and whether or not it's a general model for what other people might be able to do. Okay, just to briefly tell you the background then. So, as you can see, I work in the Medical Research Council Protein Phosphorylation and Ubiquitination Unit. So what these processes are, they are the attachment and removal of phosphate in the case of phosphorylation, or ubiquitin, which is a very small molecule in the case of ubiquitination, the attachment and removal of these to proteins. And it turns out that these processes regulate almost all biological processes within the cell. And the deregulation of these systems are actually a cause or consequence of a great many diseases. So there's become huge interest in actually targeting the enzymes which attach and remove phosphate and ubiquitin from proteins as potential targets for the treatment of disease. Phosphorylation is a much more long-standing area. Ubiquitination is really an emerging area of drug discovery. Okay, so I've been working in the area of phosphorylation now for 45 years. For the first 25 of those, no pharmaceutical industry had the slightest interest in anything I was doing. The situation changed in the mid-1990s when it became clear from several programs, two of which my unit was involved in at the time, that it was actually possible to develop potent and relatively specific inhibitors of the enzymes that attach phosphate to proteins, which are called protein kinases. So from my standpoint, having seen that it was possible to make these small molecule inhibitors, I was interested, one, in using these molecules to actually enhance my own research, because I could see they were very powerful probes of the systems I was studying. And obviously, from the other hand, there was the possibility of helping the pharmaceutical industry to launch and accelerate their programs in this area, because at that time, most of them didn't really know anything what was going on, in the system. So just to give you briefly the history, the first kinase inhibitor was approved for the treatment of a rare form of leukemia in 2001. It had spectacular effects, which is really what galvanized the area forward. There's now about 30 of these compounds that have been approved for clinical use. So far, virtually all of them are in the field of cancer. They're making a lot of money. There's a huge number of other drugs in clinical trials in this area, and a significant number are in phase 3. But the important point is that right now is that only about 30 of the 500 kinases encoded in the human genome have really ever been targeted for drug discovery. And so there's a huge potential of developing inhibitors for the treatment of other diseases. And the first forerunner of these was tofacitinib, which was approved about 2.5 years ago for the treatment of rheumatoid arthritis. So actually in the treatment of chronic inflammatory and autoimmune diseases, and this is the area I'm particularly interested in at the moment, and also for example, neurodegenerative diseases, I think there's still huge potential in this area. Okay, so now with that sort of background, let me just explain this collaboration, which we call the Division of Signal Transduction Therapy. It's a sort of which I'm offering as a model for collaboration between academia and industry. Just briefly, the history. It started in 1998. The field was called mammalian kinases and phosphatases. 5 companies initially joined, and then a 6th in 2001. It was thought to be a success, and it was renewed for a further 5 years in 2003, this time covering a much larger percentage of the pharmaceutical industry due to various mergers and acquisitions. and we even made page 3 of the Financial Times for the one and only time of my life, I think. Anyway, then we've renewed it for a further 4 years with 5 of the 6 previous companies, and in 2012 the same 5 companies continued, plus Janssen Pharmaceutica, the research division of Johnson & Johnson. So, and in this last 4 years, the field has changed slightly from kinases and phosphatases to kinases and the ubiquitin system, because that's an emerging area of the of drug discovery, and in which we've built sort of huge strengths in the last few years. Okay, so so how does the collaboration work? So basically, all of the companies in the collaboration share the unpublished research, the reagents and technologies, and the know-how of the participating laboratories, and they have the first rights to license the IP that's generated, although they have to pay more for that. In contrast, any information that the academic researchers receive from any one company is not shared, and the increased value that we achieve from having been given this molecule is sent back just to the individual company. So it's a very simple model, but in practice it's worked quite well. So 75% or so of the funding is spent on fundamental research in the relevant areas. The projects are chosen and driven by the academic researchers in areas of relevance to human disease, but in consultation with the pharmaceutical partners. About a quarter of the money is spent to support a service facility, which which has huge production capabilities, a DNA cloning team, protein production and assay development team, antibody production team, and originally a kinase profiling service. So, for example, one of the things it did was to produce the reagents needed to launch a program to develop an inhibitor of BRAF, and we also did some follow-up work that eventually led to the approval of the drug dabrafenib in 2013 for the treatment of malignant melanoma. So this is just to illustrate that we make this material on a huge scale, at least by academic standards, so we've been able to launch huge numbers of drug discovery programs, and we supply very substantial amounts of material. Okay, we've also set up important new enabling technologies like kinase profiling, which has sort of led to the development of a number of biotech companies and almost a separate industry. And recently we've set up analogous, services in the area of the ubiquitin system. Okay, so why has the collaboration continued for so long? Well, first of all, we have a critical mass of leading researchers in the field. So we've got sort of 20 program leaders and 200 scientific and support staff in this area. So a big advantage for the companies is they can learn an enormous amount of what they need just from coming to one place. So it makes it easy for them. It's considered to be good value for money. They each contribute about 6 positions, but in return they get the output of 200 scientific and support staff. A lot of the reagents provided that we provide, which we provide at cost, would be far more expensive to purchase from commercial sources. Many are not available commercially. This is self-evident. Obviously, we work to industrial standards. We actually deliver what we say we can and on time, and we've proved we can maintain confidentiality. I understand from our pharmaceutical partners this is not so common actually in academia research collaboration. So that's one of the reasons for its longevity. I think it's very important that trust is created in a long collaboration, which gradually increases its value to both parties. And then the other reason it continues is that we wish it to continue. We've obviously benefited from the research support that we've received, over 100 million euros so far, and the proprietary compounds that we receive from the companies actually enhance our research, and our students and postdocs have learnt an enormous amount about how the pharmaceutical industry works. Okay, so we think it's a sort of a widely applicable model. The key ingredients are a key mass of leading researchers operating under a single agreement obviously of interest to industry. How could it work better? This is really a few points which are some of my frustrations, because I feel that actually the companies could frequently get a lot more out of this than they do. So the first thing, they all have a person who is involved in coordinating the collaboration and who has to, but what the problem is, that person has to be of sufficient seniority to see important opportunities when they arise, and also ensure that the information is relayed to the appropriate scientists in their organization at every division worldwide. I think the companies need to send more scientists to us to make sure they're not losing opportunities, but especially send much more frequently very senior members of their organization who are able to make decisions and to make them quickly. Amazingly, of course, in some years, many companies have started to cut drastically their travel budgets, which to save money, which actually is involved in less people coming to see us and us going there less. So this is completely wasting their money, which they're saving a few $1,000s in order to, in a collaboration that's costing them, more than $1 million a year. So this seems a bit crazy. I think actually we should go out to the individual divisions of the companies much more frequently than we do because of turnover in the companies. There's a lot of people who are new to this and don't really understand what's been going on for how long and what's been achieved through this. So I think we have more of an onus to go out there and be on the road more to keep explaining, what we can do to help them. My other frustration, of course, is that we can only suggest to the companies what we can do. We can't actually tell them what to do, but I sometimes wish they would take our advice when we have really cast iron evidence that their drug discovery program is totally flawed. So they've admitted to me on a number of occasions that they wish they had taken our advice several years earlier, and they would have actually saved vastly more money than they're actually even spending on our 5-year collaboration. So that's really it. I just leave a picture of our research institute, and happy to take questions after the other speakers. Okay, thanks very much.
Thank you, Philip.